In space, or like a fabric like rubber, like a trampoline net, turn this trampoline net into a pretzel and allow yourself to go backwards in time. We were able to travel from Earth to the Moon across 250,000 miles of space, land on the Moon, and then return to Earth because of Newton's understanding of gravity. Albert Einstein, the great physicist, once said that gravity is a deception. Einstein had devoted his career to revealing the reality of gravity, refuting Newton's widely held beliefs, and providing answers to puzzling time travel queries. Why is there just one way in which time travel exists? When you travel at the speed of light, why does time slow down? The most recent hypotheses and discoveries made by modern physicists attempt to provide an absurd theory of time to explain the unexplainable. Now let's learn more about the gravity theory of Newton and how it was disproved. People didn't begin to seriously question their surroundings until the 1500s. The ancient Greeks thought that gods and deities could explain and rationalize everything. By the 1500s, scientists such as Galileo and Brahe had established that Earth was a planet, and not just one. Planets in our solar system orbited the Sun. Kepler went one step farther and described how the planets and their moons moved along their own axis, resembling an elliptical orbit rather than a precisely circular one. Newton followed in the 17th century. The world has heard about the English physicist who, by accident, discovered gravity after an apple fell on his head. It is now accepted, though, that Newton did not just by chance come up with the theory of gravity. For a long while, he had been witnessing motionless things shift from their stable positions due to some unexplained force. Yes, this also involved witnessing apples fall from trees. After several hours of study, Newton finally postulated that this enigmatic force was gravity. He was also able to advance Kepler's elliptical orbit theory as a result of the discovery. The Moon, which is the closest celestial body to Earth, is only able to travel alongside the planet because of a straight-line tangent that crosses the Earth's center and holds the Moon in place beneath the planet's gravitational pull. But before Brian Cox began challenging Newton's theories, there was Albert Einstein, the renowned physicist. Though he did not explicitly refute gravity, Einstein asserted that Newton's ideas were one-dimensional. The general theory of relativity put forward by Einstein states that time and space warp and give rise to gravity. Einstein went one step farther and defined the fabric of space and time as a sheet with bends where a body's mass exceeds a threshold. Furthermore, he asserted that a clock placed inside the Earth's gravitational field on its surface would run slower than a clock placed outside of its orbit where the laws of gravity no longer applied. Gravity, which was later shown to exist between two things regardless of whether they are planets in orbit or two marbles on a tabletop, is governed by the inverse square law. According to the law, gravity is inversely proportional to the square of the distance between two objects and immediately relates to their masses. The speed of light in a vacuum would remain the same for an observer from outside, according to Einstein, who also claimed that the laws of physics apply to everyone not speeding faster than light. According to Einstein's theory, space and time are one and the same thing, or the space-time continuum, and gravity results from a bend in this continuum. Gravity is not a force. As a result, the explanation of Newton's ideas by Brian Cox becomes essential. Although Newton is regarded as one of the greatest physicists of all time, the contemporary physics community doesn't exactly hold him in high regard. Among those in that circle is Brian Cox, who clarified that although there are those who believe Newton was lying about gravity, he did not fully define the apparent force. Cox contended that Newton was merely attempting to provide an explanation for a fundamental idea that was universally understood and accepted. One explanation for the lack of interest in Newton's day and age was the greater dominance of religion over science. Newton was a religious man. Nonetheless, he couldn't, or perhaps didn't want to, continue developing the theory of gravity past an explanation of the force. According to Cox, when explaining gravity, Newton just stated that its presence indicated that a sentient entity had authority and controlled the planets and solar system. That was as far as Newton was prepared to go. Thus, how could one overcome gravity and subvert the principles of physics, which encompass the laws of time? Really, is it that easy? In order to live on Earth, you have to genuinely defy the rules of physics. According to Newton, gravity is an intrinsic force that the Earth possesses and is responsible for directing everything toward its center. According to Einstein, space and time functioned as a fabric, and that is why objects are drawn toward the center of the Earth rather than by a force. Here's a better way to picture this. Picture a long trampoline. Now picture putting a bowling ball on the trampoline at an arbitrary location. It is evident that the bowling ball's bulk is precisely sufficient to cause a dimple in the trampoline. Step over to the trampoline and toss a stone onto it. Then what occurs? The marble rolls naturally in the direction of the dimple the bowling ball created. You will notice that heavier things like tennis balls don't fall toward the dimple created by the bowling ball as easily as the marble did when you gradually begin replacing the marble with them. Similarly, if you drop something with a significant and similar weight to the bowling ball, for example, another bowling ball, it would not go toward the dimple made by the original bowling ball but instead would make its own. This is an oversimplified explanation of what occurs when we consider the Milky Way's governance by the fabric of space and time. The Moon is our natural satellite, and the indentation the Earth made only draws the Moon toward it, allowing it to remain in its orbit. The Moon's weight is obviously insufficient to resist the pull of Earth's orbit but sufficient to allow it to exist in its own space on the fabric of space and time. This is the only reason it isn't falling freely. Similar to how the Earth may be drawn to the dent or curvature made by the huge Sun, it is prevented from obliterating into the Sun by its substantial mass. As a result, Newton's gravitational laws disregarded the actual effects of gravity and how they affect our environment. A useful use of general relativity was demonstrated in 1919 during a solar eclipse. Because they are huge enough to escape the curve of the Sun, stars fall freely. Occasionally, though, a lighter star finds itself caught in the Sun's orbit. Because of this, the Sun's rays are obstructed from reaching Earth, resulting in a solar eclipse. How time is affected by gravity. Einstein utilized certain cosmological constants in his calculations to establish the connection between the general theory of relativity and our cosmos. It wasn't until much later that it was realized the cosmos is constantly expanding rather than remaining constant. Then Einstein described this as his greatest error to date. However, the Big Bang and the ripple effect are two natural occurrences explained by the theory of general relativity. Albert Einstein postulated that heavy objects cause ripple effects in the fabric of our universe as they move across time and space. This is perhaps something you still remember. General relativity provides an explanation for how the universe evolved from a very hot and dense condition. The idea describes how Einstein's famous equation, matter and energy influence the geometry of the cosmos and represent the expansion of space and time. Following his correction of his equation to account for the universe's perpetual expansion, Einstein concluded that certain galaxies are driven apart by the universe's expansion. This aligned with observational data collected about concurrently with the publication of Einstein's ideas. The general relativity equations of Einstein aid in our comprehension of the properties of the early universe. They provide an explanation for the origin of our cosmic environment and provide credence to the concept of a primordial singularity. One of the most basic ideas in Einstein's general theory of relativity is the idea of a ripple in spacetime. It follows that large objects like black holes and stars have the ability to cause the spacetime fabric to curl around them. On the other hand, they are non-stationary objects that can produce gravitational waves when they accelerate or interact significantly with other gravitational fields. These waves are referred to as ripples in the space and time continuum. Accordingly, if something were to disturb the spacetime fabric, it should cause ripples in space, which are what we now refer to as gravitational waves. These waves or ripples can travel through space at the speed of light, carrying with them data about shifting gravitational fields. Although gravitational waves were hypothesized long after Einstein published his general theory of relativity, they weren't mathematically confirmed until 2015. They were confirmed in 2015, 100 years after Einstein's 1915 prediction, by the laser-based LIGO ground-based observatory. This most recent finding demonstrates that they are more common and can be detected at far longer wavelengths. A new era in observational astronomy was ushered in 2015 with the groundbreaking detection of gravitational waves by the Laser Interferometer Gravitational Wave Observatory, LIGO. This idea was named the ripple effect because, in principle, it resembled the ripple that results from dropping something into a still pond. From the disruption-causing object, the ripples radiate outward. This theory has made it easier for scientists to detect astronomical occurrences like black hole and neutron star collisions today by providing a glimpse into the invisible. This also contributed to our growing comprehension of the universe. The dilemma of chronological protection. Yes, most people agree with Einstein's theories. That doesn't mean, though, that the physics community hasn't discussed and refined Einstein's theories of relativity or other tenable theories. Stephen Hawking proposed the chronology protection hypothesis in 1992. The idea was presented by Professor Hawking in a 1992 study where he noted, "It seems that there is a chronology protection agency which prevents the appearance of closed time-like curves and so makes the universe safe for historians." Professor Hawking is a very dry comedian. After decades of trying to figure out why time was not a constant, Einstein developed this theoretical proposal to explain the idea of time travel. Time loops and backward time travel are theoretical possibilities, according to Stephen Hawking. This hypothesis helped people comprehend the limitations and possible effects of the conventional principles of physics. Intellectuals are still fascinated by the investigation of these contemporary ideas since it opens up new possibilities for comprehending the essence of life. Do you still believe much has to be discovered, or do you think the concept of space and time is as straightforward as we originally thought? Tell us in the comments below. I appreciate you seeing what. We'll see you with a new video soon.